Hello friends, are you struggling to find the general term of a quadratic sequence? Because in high school we have been taught to find the general term of quadratic sequence in rather lengthy way, and it's very tiresome to find the quadratic sequence formula. Here we will use a simple idea to find the general term of quadratic sequence. So let's get started with the question. The question is, it gives a sequence like this: 1, 0, 3, 10, 21, and so on. So let's first find out the consecutive differences between them. For example, 0 minus 1 is minus 1, 3 minus 0 is 3, 10 minus 3 is 7, 21 minus 10 is 11. So these terms will be the first differences of the sequence. Now let's again find out the difference of these consecutive terms. So the result will be 3 minus 1 will get 4, 7 minus 3 is 4, and 11 minus 7 is 4. Since we got the second difference as same, that is 4, so it is called as a quadratic sequence. The term quadratic means simply 2. So in a quadratic sequence we use two steps of finding differences to get the constant difference. Or in other words, quadratic sequence means we have to find the consecutive differences 2 times to get a constant difference. So this term 4 is called the constant second difference. Now to find the general term of the quadratic sequence, we will proceed as follows. In classical approach, we use this formula of nth term as an squared plus bn plus c. Since quadratic sequence, we have already discussed that the quadratic sequence is related with the number 2, so it is formed by a polynomial in degree 2. So n will have a highest degree of 2. So the highest power of n in this nth term will be 2. So it will be in the form of an squared plus bn plus c. But in our method we are not going to use this term, but we will use rather a simple formula like this. We are replacing n squared with n minus 1, n minus 2, and we are replacing n with n minus 1. We are doing so because it will be easier for calculation. We will do a calculation and you will be clear how it will be helpful. Let's go to this example and let's put n equals 1. When n is equal to 1, the first term will be 1. So the first term will be 1, and in this nth term, when we put n equals 1, it will be n equals 1. The benefit of using this formula is that since we are putting n equals 1, the n minus 1 term over here and n minus 1 term over here will get cancelled to give 0. So we will finally remain with only the term c. So we can easily find the value for c is equal to 1. Now similarly let's put n equals 2. At n equals 2, the term has got the term 0. So this term should give 0 at n equals 2. So replace n with 2 to get this result. And here also the term having n minus 2, that is 2 minus 2, will get cancelled. And we will only remain with the term b and c. But c we have already found it to be 1. So we put c equals to 1. And this will be simplified as b times 1 plus 1 equals 0. And b can be found out to be minus 1. And the same process is continued and we put n equals 3. In the same equation, when n equals 3, the term is 3. So the third term of the sequence is 3, and we put n equals 3 in this equation to give this result. And since b we have already found it to be minus 1, and c we have already found it to be 1, so we put this result, and by further simplification we will get this result, and then we will get the value of a as 2. So let's collect these coefficients a, b and c like this. A is equal to 2, b is equal to -1 and c is equal to 1. And since this is the nth term, we will put the values in this equation to get the result. A equals 2, b equals -1 and c equals 1. And with a simple simplification we will get this, and on expanding these terms we will get this result, and finally we will reach to this result. So let's check by putting n equals 1. When we put n equals 1 in this formula, we will get 2 into 1 square minus 7 into 1 plus 6, which is 1. That's correct. When we put n equals 2 in this equation, we will get 0, which is correct. And when we put n equals 3, so we will get 3 in the nth term, so it's correct. So in summary, what we can say is, to find the general term of quadratic sequence, we can use this formula because it's important, because when we plug in n equals 1, this term will get cancelled and this term will get cancelled, so we can easily find out the value for c. Similarly, when we put n equals 2, this term will get cancelled since there is a term n minus 2, so we can easily find the value of b. So instead of solving the long simultaneous equations, it's very easy to calculate because we don't need to solve any two linear equations. So the process is simple. Just put n equals 1 to find out the value for c, put n equals 2 to find out the value for b, and just put n equals 3 to find out the value of a, and just simplify, you will get the result to find the quadratic sequence. So thanks for watching.